Everyone, it's Mahesh Shiro, professor. So today I'm going to tell you the problems related to the flexure. Okay, so that is a unsymmetrical eye section has an overall depth of 2000 mm. Top flange is 1200 mm and 300 mm. Bottom flange is 750 by 200 mm and web thickness is 300 mm. Cross section area of tendon is 7000 mm square are located 200 mm from the soffit. The ultimate compressive strength of the concrete is 42 Newton per mm square. Tensile strength of the steel is 1750 Newton per mm square. The tendons are effectively bonded. Estimate the flexure strength. Okay, this is the problem they are given. So it is I section of flange width 1200, depth 300, then overall depth is 2000 mm and web thickness is 300 mm. Then bottom is 750 mm width, bottom flange depth is 200 mm. Okay, therefore here AP is equal to 7000 mm square, FCK is equal to 42 Newton per mm square, and FP equal to 1750 Newton per mm square. So they are given the effective bond of then it is a post tension. Okay. First of all, we assume that neutral axis lies in the flange. That is, XU is less than depth of the flange. So if it is less than depth of the flange, then MU is equal to FPU into AP into D minus 0.42 XU is the formula to find ultimate moment of resistance, that is MU. So from the IS code 1343 in 1980, table number 11, page number 59, okay, you will get a ratio of AP, FP, BD into FCK. So therefore AP is equal to 1000 into FP is 1750 divided by 1200 into 1800 into FCK is 40. So that ratio is 0.135. Okay. So you have to find XU upon D, where XU is the depth of the neutral axis. So from the table, so for this 0.135 lies between 10 0.10 and 0.15. So for 0.10 it is 0.217 and we want the value for 0.135, that is how much that is, and 0.15 is 0.316. Therefore XU upon D is, by interpolation we will get this intermediate value, that is 0.286. Therefore XU is equal to 0.286 into depth. So that is 0.82 0.8 0.286 into 1008, and that is 504.8 mm. So greater than depth of the flange, that is 300 mm. Okay, depth of flange is 300 mm. We got a neutral, that is XU is equal to 514, so that is greater than the flange. So hence assumption is wrong. Therefore neutral axis lies within the web. Therefore then axis of the cable, therefore axis of the cable, therefore area of resisting force is equal to APF is equal to 0.45 FCK into DF into BF minus BW divided by FP, that is equal to 0.45 into FCK 42 into depth of flange 300, then BF is equal to 1200 minus BW is equal to 300 divided by FP is 1750. So they will get APF is equal to 0.22916 mm square. Then we have the formula APW equal to AP minus APF. AP area pre-stressing web equal to area pre-stressing minus area pre-stressing flange. So that is area AP we know and APF we know, that is 7000 minus 2916, that is APW is equal to 4084 mm square. So from the table number 11, page number 59, from IS 1340 1980, APFP BDF is equal to APW into FP divided by BW into D into FCK, that is equal to, so 4084 into 1750 divided by BW is breadth of the web 300 into depth overall 1800 into 42. So this value comes to about 0.315. Again, you have to find if it lies at the web, then ratio is FPU divided by 0.87 FPU to find. And so for this values, so we got 0.315 in between 0.30 and 0.40, which is in code book. Then this interpolated value you have to find, that is comes to about 0.835. So FP equal to 0.87 into FP, so that is equal to 0.835 into 0.87 into FP is 1750. Therefore FP is equal to this much value will be getting, so that is 1 to 127.28 Newton per mm square. Okay, therefore XU upon D is equal to how much you have to find, that is therefore XU for this value you have to find, therefore XU is equal to 0.572, XU is equal to 0.572 into depth, that is D 1800, so XU is equal to 1029.6 mm. Finally MU equal to FPU APW D minus 0.420 XU plus FP into APF into D minus df divided by 2. So this is for the formula to find ultimate moment of resistance which lies at the up. Therefore mu equal to 127.28 into APW is 4084 into depth is 1800 minus 0.42 into XU is 1029.6 plus 1750 into 2916 into 1800 minus 300 divided by 2. So mu is equal to 7.100 into 10 raised to 9 plus 8.4 into 10 raised to 9, that is mu equal to 1.55 into 10 raised to 10 Newton mm. Okay, then next problem. A pre-stressed concrete simply supported beam, rectangular in section of 200 mm wide and 500 mm deep, is pre-stressed by a tendon having an area of 600 mm square located at 100 mm from the soffit of the beam. Given FCQ equal to 14 Newton per mm square, FB is equal to 1600 Newton per mm square. Estimate the ultimate flexure strength of the beam for the following cases as per IS code recommendations. Okay, if the beam is pre-tension, first case is if the beam is pre-tension, second case if the beam is post-tension with effective bond, and third one is post-tension unbonded. Okay, so figure as the rectangle section 200 by 500, then this will be area of pre-stressing, so that depth will be 400 minus of D. So here it is, AP given 600 mm square, FCK 14 Newton per mm square, FB equal to FP, that is equal to 1600 Newton per mm square, D is equal to all depth is equal to 400 mm. So first case of the beam is pre-tension, so mu equal to FPU AP into D minus 0.42 XL. Therefore AP FP BD FCK into FCK ratio is AP is 600, FE is 1600, breadth is 200, depth is 400 into 40, that comes to about 0.3. So from the table 11 IS 1340 1980, page number 59, Fp upon 0.87 is equal to 1. Okay, therefore Fp is equal to 1 into 0.87 into Fp equal to 1 into 0.87 into Fp is 1600. So Fp is equal to 1392 Newton per mm square. Then Xu upon D is equal to 0.655. Therefore X is equal to 0.655 into 400, that is X is equal to 262 mm. Therefore M is equal to 1392 into 600 into 400 minus 0.42 into 262. Therefore M is equal to 42.17 into 10 to the 6 Newton per mm square. First case is over. Then next one is second case. If the beam is post tensioned with a effective bond, APFP BDFCQ is equal to 0.3. Therefore FPU 0.8 and FP is equal to 0.85. Therefore FP is equal to 0.85 into 0.87 into 1600. Therefore FP is equal to 1183.2 Newton per mm square. Then Xu point is equal to 0.558, and then for X is equal to 0.58 into 400, that is equal to 223.2 mm. Therefore M is equal to 1183.2 into 600 into 400 minus 0.420, 223.2. Therefore M is equal to 217.41 into 10 to the 6 Newton mm. So second case is over. I remain in last case. Okay, that is if the beam is post tension unbounded. So APFP BDFC equal to 0.3. So L by D is equal to, if it is unbounded means you have to go for L by D ratio. So 5000 divided by 400, that is 12.5. Okay, assume that is equal to L equal to 5 meters. FP equal to how much? Therefore FPU upon FP is equal to interpolation will get 1.242. Therefore FP equal to 1.242 into FP. So that comes to about FP equal to 1987.2 Newton per mm square. Therefore ME equal to FPU AP T minus 0.42 XU. Okay, ultimate moment resistance. Then you have to find XU upon D. Therefore XU upon D is equal to 0.625. And then X is equal to 0.625 into depth, that is 0.625 into 400, that is X is equal to 250 mm. Okay, then M equal to 1987.2 into 600 into 400 minus 0.42 into 250, that is M is equal to 351.73 to 10 to the 6 Newton mm. Okay, this is the second problem completed. Then third problem, a pre-tensioned pre-stressed concrete beam having a rectangular section 150 mm wide and 350 mm deep has an effective cover of 50 mm if FCK equal to 14 Newton per mm square and FP is equal to 1600 Newton per mm square, and the area of pre-stressing steel AP is equal to 461 mm square. Calculate the ultimate flexure strength of the section using IS 1343 codal provisions. So cross section 450 by, that is 150 by 350, FCK 40 Newton per mm square. Then FP is equal to 1600 Newton per mm square, AP is equal to 461 mm square, D is equal to 350 mm. Okay, we have to find M equal to how much? Therefore M equal to FU into AP into D minus 0.4 to XU. Then effective ratio, that is APFP BDFCQ is equal to 461 into 1600 divided by 150 into 350 into 40, that is 0.35. Then ratio for FP upon 0.8 and FP is equal to how much? So this value lies between 0.3 and 0.4. So for the 0.35 how much? So for 0.35 it will be 0.95. So therefore here we are getting FPU upon 0.8 and FP is 0.95. Therefore FPU equal to 0.95 into 0.87 into 1600. Therefore FPU equal to 1322.4 Newton per mm square. Therefore XU upon D is equal to, we have to find XU upon D is equal to 0.719 for interpolation. Therefore XU equal to 0.719 into D, that is 0.17 into depth 350. XU is equal to 51.6 mm. Therefore mu equal to 1322.4 into 461 into 350 minus 0.42 into 250 1.65, that is equal to mu equal to 148.936 Newton per mm square. So next we will continue the next problem. Thank you.